Okay, part 10 of applied math for game development. This is set theory, just the basics. So set theory involves sets, and a set is just a collection of things. These things are called elements or members. For example, you could have a set of people, a set of colors, or a set of numbers. Now in maths, when we talk about set theory, you're not allowed to put duplicates in a set. And sets are shown as braces with members inside separated by commas. For example, the set of prime numbers, 2, 3, 5, 7, etc. You can see the three dots, the ellipsis at the end there, indicates that it continues on forever. The set of integers, you can see it has ellipsis on either side because it continues on infinitely towards the negative and towards the positive ends. But sometimes there's a fixed number of elements. The set of days of the week has Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. But you can also use empty brackets or that zero symbol to indicate empty sets, things that contain nothing. So another way you can do this is to use set builder notation, because some of these sets can get really big. And so instead of detailing all of the contents of the set, you say how to check whether any given thing is a member of the set. For example, this here says this set contains every x where, that symbol should really mean where, think of it as that word. So this set contains every x where x is a member of the set n and x is less than 5. So x is a natural number and it's less than 5. There's only 4 numbers that fit that bill. 1, 2, 3, and 4 are natural numbers and they are less than 5. That's a very long-winded example for such a crappy small thing, but imagine if that was less than 5,000. I wouldn't want to sit and write them all out. You wouldn't fit them all on one line, that's for sure. It would save you space then. I think I've just explained that. Okay, so membership in a set, that sort of E symbol we just saw, that's is a member of symbol. And the thing on the left of the symbol is a member of the set, which is to the right of the symbol. You can also use that same symbol with a slash through it to say not a member of. So for example, the value true is a member of the set of Boolean values. There's only 2 things in the set of Booleans, by the way, true and false. The number 420 is a member of Z, the set of, what's Z again? Rational numbers, I think. Pi is a member of the set of irrational numbers. But pi is not a member of the set Z of rational numbers. Next up, we've got subsets. There's the symbol for subset there. So a subset shows that one set is contained within another set. So everything in the set on the left is also in the set on the right. For example, every rational number is a real number. And of course, just the same as before, you can put a slash through it to show that it's not a subset. For example, the set of Booleans is not a subset of real numbers. Booleans are not real numbers. If you see it without that line underneath, this means it's a proper subset. And a proper subset, well, compared to a normal subset can be smaller or the same size as the set that it's within. But a proper subset is always smaller. Conversely, you've got supersets, and it's just the same idea flipped around. So that symbol is the same thing, pointing left away. So Q is a superset of R. And you can put a slash in, showing that something is not a superset. And you can put no line in, showing a proper superset, which is definitely bigger. So that leads us on to Venn diagrams. These are diagrams where sets are shown as circles, which might be separate, containing one another, or overlapping. Here's an example. This sort of onion skin here shows all the real numbers, which contains all the algebraic numbers, which contains all the rational. What's that? No, Q's. I forgot my sets here. But that definitely contains all the rational numbers, integers, and primes is the smallest set there. So different types of numbers. Different sets of numbers contain other sets. There we go. R is real numbers, A is algebraic numbers, Q is rational numbers, Z is integers, N is natural numbers, and P is primes. So every prime is a natural number. Every natural number is a rational. Every rational is an sorry, and every I missed one. Every natural number is an integer. Every integer is a rational. Every rational number is algebraic. Every algebraic number is a real number. Okay, so magnitude of sets. This is also called cardinality, and it's just a count of how many things you've got in a set. Just like other magnitudes, for example, absolute or vector magnitudes, which we'll see a bit later, we just put lines on either side of it to indicate the magnitude. So the magnitude of the set of booleans is 2. There's only 2 options, true or false. How many days are there? 7. Sometimes, obviously, the magnitude is infinite. So we can do set operations. And the first one we'll be looking at is the union operation. You combine 2 sets together. The yellow area shows the combination of sets or union of sets A and B. A union B, that's the union symbol there. Unions will not result in duplicates because you're not allowed to have duplicates. So if you take the set that contains 1, 2, 3, and 4, union it with 4, 5, 6, and 7, 4 appears twice, but in the answer it will only appear once. The duplicate is removed. Now union is commutative. A union B is equal to B union A. It's also associative, so you can take the brackets around A union B when it's union with C and put them on B union C instead. You can move the brackets around as long as it's all unions. We're all good. You can unite any set with an empty set. There's the empty set there. If you have A union empty, you'll get A. It's kind of equivalent to saying A plus 0, I guess. Next operation we've got is intersection. There's a symbol for it there. And the yellow region shows you intersection between set A and B. So you look for entities that appear in 2 different sets, the overlap between them, in other words. If there's no overlap at all, which can happen, then the sets are said to be disjoint from each other. Intersection is commutative. A intersection B is the same as B intersection A. It is associative. You can move the brackets around 2 operands to the other 2 operands. And if you do intersection with the empty set, you'll end up with the empty set, but sort of equivalent to saying A times 0. Now we've got the difference operation. You take one set and remove everything from that set that appears in some other set. That usually has this slash symbol. So this is also called the complement. Difference removes any elements from one set that also happen to be in another set. For example, if you take the set 1, 2, 3, and 4 and do a difference with 3, 4, 5, and 6, we're going to remove the 3 and the 4. There is no 5 and 6 to remove, so we ignore them, and we're left with the set containing 1 and 2. Take any set and do a difference operation with the empty set. You're removing nothing, so it's like saying minus 0, and you'll just get the same set you started up with. Here's another example. Take the real numbers and remove all the rational numbers. You'll be left with the irrational numbers. So in maths, a set can contain an infinite number of elements. Computers, though, don't have infinite memory, so we can't really do that. So in programming, basically sets are likely to be things like arrays or similar structures. C#, for example, has a class known as a hash set. This implements sets. It also happens to implement hashing, which is technically unrelated, but it goes together quite well. Hashing creates keys for each entity. So each thing in your set also has a key, which is unique, and that makes searching for an item quicker, and also makes it easier to ensure there are no duplicates. That's why hashing is used for sets in C#. It's easy to remove duplicates. So declaring a hash set is just like declaring a list in C#. You say hash set, and then put in angle brackets the type of object you're making a set of. So I'm going to make 2 sets here, first set and second set. Instantiating it, we're going to say first set equals new hash set, just an empty set. We can then add things to the set. You say add a number. Or you can populate it in one go, same as you can with lists and arrays and other things. You can fire a new array straight in there. We've got a set containing 3, 4, and 5. You can do intersections. You can do first set intersect with second set. You can do union with. And you can do a difference or except in C# it's called an exception. So we do except with the second set. Oh, sorry, these are destructive operations I should mention. When you do first set dot intersect with second set, it will actually change the contents of first set, which is different from how programming languages typically do algebra. Because I mean, it's not in a computing sense, it's not really an algebra operation. It's a set operation, sort of, that modifies your structure. So just bear that in mind. If you want to make a third set, which is the intersection or union, you may need to make a copy of one set and then do an intersect. And that's about it for sets just now. I'll leave the rest for later.